Welcome to part 2 for making the plug of the right rudder of the UWS-1 Ultralight airplane. From the Ultralight Airplane Workshop, my name is Leon. If you haven't seen part 1 of the video for making the plug of the right rudder of the UWS-1 Ultralight airplane, I'll put a link in the upper right hand corner that you can click on and go take a look at that video. If you don't look at that video, some of this won't make any sense to you. In this part of the video, we're actually going to start making templates and foam parts and assembling the plug for the right rudder. Now, when I say plug, I'm talking about making a version of the right rudder that we will then use to make a mold, and then from that mold, we will actually make the right rudder parts. Well, let's get to it. You can see in this video clip the next thing that we need to build for the plug for the right-hand rudder of the UWS-1 Ultralight airplane. We need to make templates to cut the foam for our plug. And here you can see the airfoil shapes that are going to be used for the foam. And you can see the plan forms for the various foam sections. And I've laid them out here in the order that we'll use them on the rudder. But to make these templates, we need to know what their shape is going to be. In order to do that, I cut up the foam portions of the plug using CAD, Computer-Aided Design Program. And in CAD, I used the technical drawing capability to get the profiles of these templates, and then I printed those out on a laser printer. When I saved the technical documents, I saved them to a PDF format file, and then I used Acrobat Reader in order to print them out. And one of the nice things about Acrobat Reader is that if the paper size of your technical document is bigger than the sheets that your printer prints, it will actually do something called posterize. And it'll use several sheets to print those out. And so that's what I did with my PDF files. I used legal size, so that's 8.5 by 14, since my printer can print sheets that large. And for example, in this case, it used 3 sheets to print out this plan form template. One of the nice things that it does is that you can select cut marks over here, and when it prints it out, it will print little marks in the corners of these sheets. And if you line these up, then the lines of your part will be lined up. Here I'm pointing out the corners of the sheets where the cut marks are. The middle sheet has it in 4 corners, the side sheets just have it in 2 corners, where those corners should overlap. But what I'm going to do is I'm going to cut along those corners. I'll do that on each sheet, and then I will butt the sheets up together, and then everything will line up. I then use scissors to cut out all of my paper templates to within about 1/8 of an inch of their outline. The next thing to do is to glue the paper templates to the wood so I can cut those out for the templates to use on the hot wire machine. In this case, I'm using a 1/2 inch piece of plywood for my end airfoils. I want to be able to put a long clamp between the top and the bottom ends on my plug, just in case I need to squish them together just a little bit because maybe there's too much gap in between some of my foam pieces and I need to get it down to the correct size. So for the ends, I'm using 1/2 inch plywood. What I'm going to use is epoxy, a thin epoxy, to glue the paper to the plywood. I put a coat of epoxy on the wood first. I put a little bit extra on because some of it's going to soak in, and I want to have a little bit that will soak into the paper. Next, put the paper template on the wood and press it down and wait a little bit until the excess epoxy from the wood will soak up into the paper. And then if it looks like there isn't quite enough soaked into the paper, I'll put a little bit more on top of the paper. Once I'm happy with how much epoxy has soaked into the paper, I'll then use a squeegee to remove any excess because I don't want any bubbles under the paper or extra drops of epoxy on top of the paper. I want it to be fairly smooth because on these airfoil shapes, these faces are going to be glued up against the cutout foam, and so I want it to be fairly flat. All of the plan form templates and all of the airfoil templates, except for the end templates, are all made out of 1/8 inch plywood. And this happens to be plywood that I just happen to have laying around the shop. And all the paper templates you see me laying out here, each one was able to be printed on just one legal size sheet of paper. And I'm doing them all together right here. The paper templates really aren't too hard to put together on the plywood. All of them have lines that are perpendicular to the cut, so it's easy to line them up. And all you have to do is butt the edges up together. and it works out great. You just have to be careful that you don't put too much epoxy underneath that it kind of floats the paper and then the paper wants to move around. After the epoxy has cured, it's time to cut out the templates on the bandsaw. I like to cut up to within about a 1/16 inch of the line. I mean, the closer I can get to the line cutting with the bandsaw, the less sanding I have to do with the sander. The bandsaw cuts much faster than the sander does. When I'm cutting curves, I don't necessarily get up to within a 1/16 inch of the line. On curves, it's okay to have some pointed edges, some corners, because the sander will knock down corners pretty fast. Speaking of sanders, in order to sand the edges of these templates, these wood templates anyway, a benchtop disc sander or a wide belt sander, wide being probably 4 inches or more, is far preferable than a narrow belt sander or even doing it by hand. And you want that sander to have an adjustable table so you can set the angle between the table and the disc or belt so that you can get the desired angle you want on the template. In my case, I want right angles on all my templates. You may have noticed when I first started sanding this airfoil template, I went to the nose and I knocked those corners down first and got within about a 1/16 of an inch of the line, and I knocked all those corners down first. That way when I'm sanding from about a 1/16 of an inch down the line, I can get in a groove and I'm doing it the same way all the way around. And my flow is not then getting interrupted by dealing with the corners in the middle of sanding. And I also sometimes do this in 2 steps, where I come down to about a 1/32 from the line, and then I come back again and I go down right to the line or about halfway through the line. Generally, your disc sander or belt sander will have a fairly coarse sandpaper on it. It could be 60 grit, 80 grit, you could even go down to something like 40 grit. And that's going to leave very coarse marks on the edge of your template. When you go to run your hot wire over that template, it's going to be in the same orientation as those sand marks. And that's going to make it a little bit rough, a little bit catchy for that wire to run across those sandpaper marks. Well, we really want our hot wire to run over the template smoothly. So what I like to do is get a sanding block with some slightly finer sandpaper, anywhere from about 100 grit up to about 200, 220, something like that, and either remove those coarse marks made by the sanding disc or belt sander, or at least change the direction of them so that those marks won't catch on the hot wire. The other thing I like to do is try to remove any excess template that's still there. There are occasionally spots where I don't quite get down to my line, so I go ahead and use the sanding block to sand down that last little few thousandths of an inch to get down to my line. Any place that I've made a little mistake and left a little too much template there. I had this 3/4 inch thick polystyrene foam from an earlier project that I thought I could go ahead and use for these smaller parts. I didn't have my hot wire cutter yet at the time, so I used a razor knife to roughly cut out the foam pieces just a little bit bigger than the shapes that I needed. Then I would glue these together in a stack to get the size of foam that I needed. Cutting through an epoxy joint using a hot wire cutter is kind of difficult. I mean, it can be done, but it really slows things down. So what I do is I draw approximately where the airfoil shape is going to be cut on the foam. When I place the epoxy, I place it well within that outline. So when I cut the airfoil shape out with the hot wire, I'm less likely to cut through epoxy. Now it's time to start gluing together stacks of foam. This first stack I'm going to work on is the very top stack, between the top of the rudder and the next airfoil template down. It's about 2 inches tall, as you can see here from the profile template. And that's from the very top of the rudder down to the next airfoil template below it. Since it's only about 2 inches tall, it only takes 3 of these slices of 3/4 inch thick polystyrene foam to get the tallness that I want. I've already marked out roughly where the airfoil shape is going to be on these 3 pieces of foam. I'll apply just a little bit of epoxy to the center of these airfoil shapes. And as I said before, I generally put the epoxy near the center of that airfoil shape. I don't want it to leak out past the edge if I can avoid it, just because it's a little hard to hot wire through that epoxy. And then I'll stack the three together and I'll put a weight on top of it. To help distribute the weight a little bit, I'll put a piece of plywood on top and then put the weight on the piece of plywood. And that helps distribute the weight from the front to the back of the airfoil shape. And then I proceed on to the next block of foam. This one is 4 inches tall, so it takes 6 of these 3/4 inch thick pieces of foam. And again, I just use the same procedure. Put epoxy in the middle of the airfoil of each piece of foam. I stack each piece of foam, then put a weight on the top of it. I do have a few sections on this plug that are 8 inches tall. And since I happen to have some 1.5 inch thick foam, I decided to go ahead and use that for these 8 inch tall sections. And in addition, the airfoil sections here are a little bit longer than my little pieces of 3/4 inch thick foam can handle, so I had to use some different foam anyway. There is a reason for having some 4 inch sections and some 8 inch sections. I wanted to see if there was much difference in how difficult it was to sand the 4 inch section versus the 8 inch section. I would think that the 4 inch is a little easier because there's less distance between templates and you're likely to get more accurate contour. I wanted to see if the 8 inch sections weren't too difficult because it's a little bit less work to put together the 8 inch sections. If they're not too difficult to sand, then that would be the way to go. But otherwise, there's no difference between the 4 inch sections and the 8 inch sections as far as assembly of these foam block sections goes. Since I cut these little foam blocks out kind of haphazardly, very roughly, and not uniformly, it's a little bit difficult to get the airfoil shapes to line up on each of the blocks. So I put some alignment lines at the center of the leading edge of the blocks, and so I kind of line those up to get left and right, or however you want to think of it, the nose correctly lined up. I did the same thing on the trailing edge. There's a line along the trailing edge to get that lined up and get that centered. And then I also put a line along the hinge line, and getting those lined up then should have all the airfoil shapes that I marked on each of these individual blocks lined up, so it's less likely that I'll end up having to cut through some epoxy when I go to hot wire the entire assembled block. So I kind of been learning better ways to do this as I've been going along. And speaking of possible ways to make things a little bit better, here's another experiment I'm running. On one of the foam blocks, I've decided to only use 2 pieces to make one of the 8 inch tall blocks. In this case, I've turned the glue seam so that it runs along the axis of the rudder. Instead of the glue seam kind of running parallel to the airfoil sections, it runs parallel to the leading edge and trailing edge. Now that's kind of nice because it means I only have 2 pieces of foam that I have to deal with. I can lay the plan form template on just one of the faces and cut out the plan form, but then on an end I will have to true that up first, make it 90 degrees to the other faces, before I can use an airfoil template to cut out the airfoil shape of the foam section. But potentially this is a much easier way to assemble the foam blocks. I finally got around to building a vertical hot wire cutter that I could use to cut out the profile and the airfoil shapes of these foam sections we've been making for the rudder plug. Now most of these foam sections I made were kind of haphazardly cut out for each of the pieces of foam, and that made the face that is the profile face a little bit rough, in fact a lot rough. And so what I have to do first is on both sides of that profile face, I need to give myself a smooth face that is in right angles to the end face that I can then put my profile template on and cut out with the hot wire cutter. Now I'm going to use the hot wire cutter to give myself that flat profile face. You're seeing my first successful use of this hot wire cutter. I had an unsuccessful use just before I took this video clip where I completely destroyed a piece of foam. I made a slight modification to the hot wire cutter and now it's working pretty good. Over here on the left hand side you can see a 2 inch by 4 inch piece of aluminum tubing. Now I'm using that as my fence, and I'm just using a spring clamp on this side, and then I got a regular C-clamp on the other side to hold it in place. And I'm using that fence just to keep my block a constant distance from the hot wire in this case. since that face up against that fence is irregular at this point, I'm really just using it as a spacer. Now later, I actually use it as a fence and I push the foam up against it. What you see here is I'm doing the first cut to flatten out the planform face. Now I was actually just taking little 1/8" slices until I got it down to where I want. But this is the very first one that I took that was successful. Once I took enough cuts to get a fairly flat face on this side of the foam, I then turned around, but I still make sure that the face that is against the table is the same face. That way I can be sure my two planform faces should be parallel. If I had accidentally flipped it over and used the other end, since I didn't do anything to try to make sure that the two ends were parallel, they may not be. This foam isn't perfect, it has irregularities. So I want to be consistent and use the same end against the table as I'm cutting these planform faces. So I turned it around and I'm doing the same thing, doing 1/8" cuts, trying to get the next planform face nice and flat. The reason I'm using these thin slices now is I'm trying to get used to this hot wire cutter, and I didn't want to screw up another block of foam like I did on the previous test. So I'm kind of sneaking up on where I need the planform face to be. And as you can tell, this is running a little bit slow. I'm running the wire just a little bit cool. This is a stainless steel wire instead of a nichrome wire, so I'm not yet sure how hot I can get it and not have it stretch out or break on me. So I'm running a little bit cool, which makes it run a little bit slow as I'm cutting the foam. And another thing that's making it run a little bit slow is that even though I was trying to keep epoxy from coming out past the airfoil shapes that I had drawn on the foam pieces, some of it did go ahead and seep out, and I'm actually having to cut through some of that epoxy. And so that kind of slows things down too. I decided to turn the block around and do another cut on that first face again. I probably didn't need it. I only needed enough flat area that my template could set fairly flat, and then I could cut around the template. But I decided to get a little more experience with this hot wire cutter, and I did the first face with another slice. Next thing to do is cut out the planform on this block of foam. I use my planform template now that I've got some flat faces that I can use. I could have done one less cut if I had lined up one edge of the planform with the end face of the foam block that I had used against the table as a reference, but I decided I wanted to cut out all 4 of the edges of this block. I used nails that I pound through the template to hold the template in place. And then I adjust the hot wire cutter so that my holding arm is just a little bit above where the foam will be. And this holding arm holds the hot wire so that I don't get odd shapes to the hot wire. It doesn't bend in, out, or forward or backward. Let's speed up and we'll watch in fast time cutting the 4 sides of the planform. Here's that foam block with the planform already cut out. The left-hand side is the leading edge of the airfoil, the right-hand side is the trailing edge, and this top side is a little bit wider and the bottom side is a little bit narrower. Since I want to leave my airfoil template in the plug to use it as a sanding guide, I am gluing this airfoil template to the foam block. And to speed the process along, I decided to use some 5-minute epoxy to glue this airfoil template to the foam. And again, I want to be careful not put too much epoxy on it because I don't want it to squish out along the edges of the template and then make it difficult to hot wire the airfoil shape. And then of course we put a little weight on the top of it and let the epoxy cure. Now here's a quick view of all of the foam blocks stacked together. Now here we're starting at the top, and I haven't glued on the top airfoil section yet. And then down here toward the bottom, you can see that I've already cut an airfoil shape out on the bottom foam block. And that's the next thing I'm going to show you, is cutting out the airfoil shape. On this 3/4 inch thick foam, after I've hot wired the plan form of the foam block, it left behind these really hard strings that were kind of attached to that face. So I want to remove those by sanding that off a little bit, because that's the face that I'm going to be putting back down on the hot wire table, and I want a nice smooth reference face for when I cut out the airfoil shape using the hot wire. Before I cut that airfoil shape though, I wanted to cut the alignment holes down through the foam blocks that I'll run the steel tubing through to align all of the blocks of foam. I wanted to get an idea of how straight I'm drilling those tubing holes down through the foam blocks. So what I'm doing is I'm transferring marks for the center of the leading edge, the center of the trailing edge, and then the lateral lines that run through the center of the tubing holes. I'm transferring those down to the bottom of the block and marking those. After I drill my holes through the block, I can look and see how well I lined up with those marks on the bottom. Now there are going to be errors. There's kind of a cumulative errors as I'm trying to transfer these lines from the top of the block down to the bottom of the block. But at least let me know if I'm way out of line, or at least if I'm close. And being close is going to work okay, since I'm leaving extra foam on the block to do sanding. Being off a little bit, even 1/8 of an inch, maybe even as much as 1/4 of an inch, will still be okay. What I want to be accurate on though is the holes through my airfoil template. The next thing to do is to drill the holes for the alignment tubes that we're going to put into the plug. I decided I wanted to try to pre-drill these holes. As it turns out, it was probably okay to do it through the template, but I think it was a complete waste of time to do it all the way through the foam. But that's what I did. I wanted to do a little experiment and see if it was worthwhile. I didn't think it would be, but I went ahead and did it anyway. This is an 8-inch tall foam block. I'm using my mill to do this drilling, and the mill only has a vertical travel of 5.5 inches, so that's as far as I can drill down into the block. So I go ahead and do the 5 inches here using the mill. I happen to have a longer drill bit for pre-drilling this foam, but like I said before, I think pre-drilling the foam was a complete waste of time, but I went ahead and did it to see if I could learn anything. You can see here I was off from my mark a little bit, but it's still within tolerance. Well, now I'm ready to drill the 1/2 inch hole for the 1/2 inch alignment tube that I'm going to put in the plug. When I was drilling the smaller pilot hole, I just held the foam block by hand upright, but I wanted to make sure I had this hole square. So I put a 90-degree fence on my mill table and bolted that down. And since I've got it on the mill table, instead of moving my piece around in order to center the drill bit on my pre-drilled hole, I'm actually using the mill table to center it. I then peck this 1/2 inch drill bit down through the hole, and again I'm only getting about 5 or 5.5 inches depth on this hole. So that leaves another 3 inches I got to figure out how to drill. Now this is just the rear alignment tube, which is the 1/2 inch diameter. I also have a forward alignment tube, which is 5/8 diameter, and that forward tube goes right through the hinge line to the rudder. Now I drilled that off camera so you wouldn't have to have a repeat of this. I didn't happen to have a 1/2 inch drill bit long enough to go through this 8 inches of foam. So what I decided to do instead was take my 1/2 inch tube that I'm going to put through the plug, and I went over to the bandsaw and I cut some teeth on the end of the tube, and then I'm pushing this tube through the hole, and since I've got about 5.5 inches through the foam also, the foam was able to help guide the tube, and I just pushed and twisted that tube the last 3 inches through the foam. After it got through the other end then, you can see that the hole matches up fairly well with the alignment marks on the bottom of the foam. So I was pretty happy with that. Now, of course, I got a little foam plug inside my tube, and I have to push that out. The little 4-inch tall foams of block and the little short 2.5-inch end blocks were much easier to drill. I could just drill straight through those with the drill bit, didn't have to do any drilling with my tube. So that's much nicer. And here you can see me drilling the 5/8 inch alignment tube hole through the hinge line of the rudder plug. It's finally time to start cutting out the airfoil shapes on these foam blocks. This is one of the little 4-inch blocks, but even being only 4 inches high, it's kind of easy to not pay attention and for the block to not be flat down on my hot wire table, and I screwed up right about here. And I'll show you the result of that screw up here at the end. On almost all these blocks, I put just a little too much epoxy, or got the epoxy a little too close to the edge of where the airfoil shape is going to be. So I end up cutting through epoxy on almost all these foam blocks. But all it did was slow me down a little bit. It does leave a little ridge right there of melted epoxy that's a little bit above the foam, so it requires just a little bit of sanding to get rid of, but that's no big deal. And as you can see here on this one side, this is where I did the screw up, where I wasn't paying attention to cutting the foam block and it got away from me a little bit. But that's not a real problem. I can easily fill that with the drywall mud when I'm doing the filling and sanding on the plug. Well, now it's time to make this plug look like a rudder. We start with assembling the bottom foam part first. I'm putting the 5/8 inch tube in the hinge line hole, which is 5/8 of course. Then we put the 1/2 inch tube in the aft 1/2 inch hole. Then we just start sliding section after section onto the tubes. And let's get to that in fast motion. You're now looking at the bottom of the fully assembled plug. Now it still needs sanding and fiberglass put on it, but you can see what it's going to look like. You can see as we look at the leading edge here that each of the foam blocks starts out at the correct airfoil shape, and then as it moves toward the top, it starts getting flat along that leading edge. That's as you would expect, because each of those foam blocks was not cut on the taper, it was cut straight up and down relative to the face at the template. That is as you would expect it to be. Now as we come around the top, you can see the alignment tubes that are sticking out. Those not only align up the templates, but my intention is to screw those to some parallel boards that will also make sure there's no twist in the plug. Then as we come around to the trailing edge, again you can see where it's at the correct thickness at the template, and then it gets wider as it moves toward the top, which in this case is to the right of the plug. And again, same reason as on the front leading edge. But there is a problem. What you're looking at here is a printout of the assembly of the plug. And as you can see along the hinge axis of the plug, that distance from the bottom to the top is supposed to be 40.6 inches. I've got a tape measure laying along that hinge axis of the real plug, and let's take a look at what that hinge axis length really is. Well, as you can see, it's 39 3/4 inches. That means it's about 3/4 or 0.8 inches too short. A lot of printers, especially ones that do copies, will print out just a few percent too small. Now, one of the reasons for doing that, especially for the ones that can do copies, is that they're trying to cut down on counterfeiting. But it certainly presents a problem when you're printing stuff out. Now, I had known about this problem for years and years and years, but when I was printing out these documents, I just spaced it out and forgot about it. All I would have had to do to fix this is change the scale by about 2%. Actually, it's about 1.9, something like that. And I wouldn't have had a problem. But unfortunately, I forgot about it. Now, I could work around the problem. Since it's about 0.7 inches and I've got 7 of these airfoil templates in here, I could just add about 1/10 of an inch of space between each one of these templates. That means I'd have to do a little more filling, a little more sanding, but that would certainly work. And I could probably leave the core distance about right. A 2% difference isn't much. I could add just a little bit more to the trailing edge, and that would be fine. And as far as core thickness goes, I don't think you could even tell a difference on 2%. Although I could, again, add just a little bit more of that drywall mud and sand it to be just a little bit thicker. So I certainly could fix this issue. Or, of course, I could start over again and print the PDFs out the right size and do it all again. Now, I've given this some thought and I've decided to try something else. One of the problems I thought I might have with using this particular method of making the plug is this trailing edge would be a little bit fragile. It could easily get warped and I might have a hard time getting this back edge to be straight. Particularly if I was off a little bit drilling some of these holes in here for my tubing. That can make the trailing edge off. Then it might be a significant pain to try to get these straight. So I think what I'm going to do is something different. What I think I'm going to do is start over on the plug. But I think it'll take less effort. So here's the plan for the next plug, which will be part 3 of the video instead of what I had intended to be part 3. I'm going to use a piece of plywood that's basically the same as these thin airfoil templates. And what I'm going to do is cut out that piece of plywood for the whole plan form of the rudder, top to bottom, trailing edge to leading edge. That means my whole leading edge will be one piece of plywood. That should be stiffer and straighter than with the method I just used. That means then I'm going to have to cut more foam blocks. I'll have to have a block on top and a block on bottom, but I should only need one block in each section. Another change I think I'm going to make is make each section 6 inches wide, so I'll be consistent there. So I won't be using any of the alignment tubes like I did on this one. I will probably also embed some 1/4 inch wood spar caps in there to try to give it some rigidity. So it's not beam bending as I'm trying to apply the fiberglass layers on it. That also means all of my airfoil shapes, I'll have 2 of them. One that goes on top of the plan form and one goes on the bottom of the plan form. So I'm going to double my airfoil templates. I'm also going to double the number of foam blocks I have, but the total number of foam pieces I need to cut should be less, just one on top and one on bottom. And when I'm saying top and bottom, I'm talking about as the rudder is laying horizontally. That's the plan for part 3, making another plug for the right rudder. And it shouldn't take me nearly as long as this one did. So stay tuned for that. If you haven't subscribed to the channel and you like these composite videos and the design videos, make sure you subscribe. And to get notified, make sure you hit that bell button, and anytime I upload a video, you'll get notified. And by the way, I'm going to make a video of how I built this hot wire cutter. I'm going to put that up on Patreon for my designer and builder tier patrons. So if you'd like to see that, you might think of becoming a designer patron or a builder patron on Patreon. And there's a link down in the description. See you next time.